Students, now let us continue solving this one more important problem. This has appeared in a number of previous year question papers, so I thought of solving this problem for you. So let us start the solution first. We will consider from this problem, it's clear that the numerator is your f of z. Your f of z is sine pi z square plus cos pi z square. Okay. Now the remaining part, which is 1 divided by z minus 1 whole square into z minus 2. We need to resolve this into partial fractions. Okay. So we have got 2 points here. As you see, the denominator a equals 1 and a equals 2. Okay. So we will discuss in detail regarding the points and regarding the function later. But right now, look at the first, the denominator 1 divided by z minus 1 whole square into z minus 2. For this we have to resolve into partial fractions. So it will be a divided by the first bracket of the first square. So it will be, you have to repeat it, plus c divided by z minus 2. It will be something like this. Now let us further simplify it. Now if you solve it, it will be z minus 1 into z minus 2 appearing here, plus b into z minus 2 plus c into z minus 1 square, that equals 1. Okay. I hope this step is clear to everyone. I need not explain much over here. Okay. Now, yes, just resolving them into partial fractions, it's not a big deal. Now we will put z is equals to 1. As you see, this turns 0, this turns 0. If you put z is equals to 1, it will be minus b equals 1, or b gives you minus 1. The value for b will be minus 1. Okay. Now let us put z is equal to 2. Okay. This will be 0, this will be 0. This is 2 minus 1, it will be 1. 1 whole square is 1. So c equals 1, or directly from this equation you will get, I'll rewrite it. So you are getting 1 is equal to c, or c equals 1. Okay. Now further we'll compare the coefficients of z square. So comparing the coefficients of z square. So you see, where and all you are getting z square, it is with c and it is with a. Look at that. If you multiply z into z, you get z square, and you expand this bracket, you will have z square. So a plus c, and since there is no z square on the left hand side, it is must be equated to 0. Okay. So a plus c is 0, or a equals minus c, or a equals minus 1, because c is 1. Okay. So once you minus 1 divided by z minus 1, b value is minus 1 divided by z minus 1 whole square, plus the c value is 1 divided by z minus 2. These are the resolved fractions. Now what is your f of z? F of z is that. So f of z divided by z minus 1 whole square into z minus 2 will be what? It will be f of z minus f of z. Please make a note, there is minus sign. F of z divided by z minus 1 minus f of z divided by z minus 1 whole square you will get here, right? You have to just multiply f of z on both the sides of the equation, nothing else. Okay. So it is as good as writing this way. Okay. Now let us consider the integral of it. Therefore the integral over the curve C, f of z divided by z minus 1 whole square into z minus 2 is actually equal, dz is actually equal to integral of the first curve minus f of z dz divided by z minus 1 minus integral over the curve C. I will mention, yeah, I hope this is clear. Yes, first integral over the curve C, f of z divided by z minus 1 dz minus under integral sign f of z divided by z minus 1 whole square dz plus under integral sign over the curve C, f of z divided by z minus 2 dz. Okay, this is what you get. Yes, I hope this is clear. Now, yes, now case 1. So our simplified form of this big integral is like this. Okay, so I will call this as I1, I2 and I3. So let us call it as I1 plus I2 plus I3. So I am taking I1 as minus integral over the curve C, f of z divided by z minus 1 dz. Similarly, I2 is minus under integral sign over the curve C, f of z divided by z minus 1 whole square dz. Similarly, I'll take I3 as integration of the curve C f of z. Look at this. I'm calling each of these integral as I1, I2, I3, so that I1 is the first integral, I2 is the second integral with negative sign, I3 is f of z divided by integral over the curve C f of z divided by z minus 2 dz. Okay, these are all my integrals. Now let us, keeping these all things in our we will evaluate for different curves. We are given with 3 sub questions there. So now I have just written all I1, I2, I3 together, and with respect to each case we'll be discussing what should be their values. Okay, so now let us consider the case 1 where you have mod z is equal to 3. So what do you mean by mod z is equal to 3? As I told you, it represents a circle. Okay, now you may think how it will represent a circle. What is mod z? If z is equal to x plus iy, what is mod z? It will be root of x square plus y square, and that is been given to be 3. So if you square on both the sides, it will be x square plus y square is equal to 9, is it not? So this represents the equation of a circle with center as the origin and radius 3 units. Okay, so since it is representing the circle, we are going to draw a circle with center as origin and radius 3 units. Okay, let us draw the circle. Say this is 3. So if this is 3, okay, now what are the values for I1, I2, I3? Look at the denominators of those. The denominator of first I1 is a is equal to 1. I2 also has a equals 1, whereas I3 has a equals 2. Now let us discuss for the 2 points A1 and 2. You see 1 lies here if 2 comes over here. So both the points a is equal to 1 and a is equal to 2 lie inside mod z is equal to 3. Therefore, I1 is equal to minus under integral sign over the curve C, f of z divided by z minus 1 dz by integral formula, Cauchy's integral formula will be minus sign as it is. This integral as per the formula, it is 2 pi I into f of a. A value, look at the denominator, it is 1. Right? Now since it is lying inside the curve, that is also been satisfied. Okay, so what is f of 1? We have f of z. I'll write here f of z. Your f of z is sine pi z square plus cos pi z square. Is it not? If I put z is equal to 1 over here, it will be minus 2 pi I into sine of pi z square is 1. Because z is 1. So cos pi you get. Sin pi is 0. Cos pi is minus 1. So minus 2 pi I into minus 1 you get, which is plus 2 pi I. This is value for I1. Similarly, let us evaluate for I2. It is minus under integral sign f of z over the curve C divided by z minus 1 whole square. Now as you see, it's clear that we have to use Cauchy's generalized integral formula. So as per the formula, retain the minus sign. You have 2 pi I, the value for a is 1, and look at the value for n is also 1. So it will be 1 factorial f dash of 1 you will get. Okay, so if f of z is this, I'll write in short what is f dash of z. F dash of z will be derivative of sine, which is cos pi z square, into the derivative of pi z square. It will be 2z pi. Okay. Similarly, derivative of cos, it is minus sine pi z square into the derivative of pi z square, which is 2z pi. Okay. So this is the derivative of f of z. Now we have to find the value of f dash of z at the point 1. Okay, so it will be what? F dash of 1 we are working for. If you put z is equal to 1, yes, if you put z is equal to 1, you will have minus 2 pi I divided by 1 factorial, which is 1. Okay, into f dash of 1. If you put z is equal to 1 here, it will be 2 pi cos pi minus 2 pi sin pi. Sin pi is anyway 0. So that will be equal to minus 2 pi I into cos of pi is minus 1. So 2 pi it will be minus 2 pi. Or finally you will have, so therefore your I2 gets out to be plus 4 pi square I. Now similarly, let us evaluate for I3. integral over the curve C, f of z divided by z minus 2 dz you have, right? Just a minute. Yes. So that will be by Cauchy's integral formula. It will be 2 pi I into f of 2. Look at the denominator, the value for a is 2. So 2 pi I into f of 2. Your f of z is, yes, 2 pi I into sine of z is 2 means what? It will be 4 pi sine 4 pi plus cos 4 pi. Sine 4 pi is 0 but cos 4 pi is 1. So it will be 2 pi I into 0 plus 1, which is 2 pi I again. So you have got all these values. We will substitute in the final answer. Therefore, integral over the curve C, f of z divided by z minus 1 whole square into z minus 2 dz, we had taken it to be I1 plus I2 plus I3. So I1 value, we have got it to be 2 pi I, I2 is 4 pi square I, plus I3 is 2 pi I, or together if you write, it will be 4 pi I plus 4 pi square I. I can take 4 pi common, 4 pi I common. So what you are left with? 1 plus pi. So this is the complete solution for the first curve. Now similarly, we have to continue it for other two curves. Let's continue with that, another two curves here. Now in case 2, we have mod z is equal to half. The next circle is mod z is equal to half. So clearly, you just draw the circle. So it represents a circle with center as the origin and radius half units. Means this is half, right? So the point z is equal to 1 and z is equal to 2. Look at all the three integrals I1, I2, I3. The value for a is, right, 1, 1 and 2 here. Where the points, if half comes here, 1 will be here, 2 will be somewhere here, which is out of your this, right? So therefore, out of the circle, right? So this implies points a is equal to 1 and a is equal to 2 lie outside mod z is equal to half, right? So this implies integral over the curve C, f of z divided by z minus 1 dz is 0. Similarly, I'll directly write now, integral over the curve C, f of z divided by z minus 1 whole square dz will also be 0, and that is also equal to integral over the curve C, f of z divided by z minus 2 dz. All three are 0 because both the points are lying, the denominator points, they are lying outside the circle. Okay, so I told you the final answer for the case 2 is direct. Okay, it is 0. Let us discuss with the case 3 now. The next circle is mod z is equal to 3 by 2. So let us directly draw the circle now. So here it is. Just a minute. Yes. Yes. So we have a circle with radius as 3 by 2 means 0.5. I mean 1.5. 3 by 2 gives you 1.5. Just draw the circle. Yeah, the radius is 1.5. The point 1, it comes over here. Point 2 comes here, right? This because this point is exactly 1.5. The radius is 1.5. 1 comes here inside the circle, whereas the point 2 comes outside the circle. Therefore, the point A is equal to 1 lies inside mod z is equal to 3 by 2, whereas a is equal to 2 lies outside mod z is equal to 3 by 2. So only for, since it is point A is equal to 2 lies outside the circle. So where point A is equal to 2, where it belongs? It belongs to I3. Look at the denominator for I3. I3 you have z integral over the curve C, f of z divided by z minus 2 dz. Is it not? So therefore I3 integral we can directly take it to be 0 because the point A is equal to 2 lies outside the circle. Therefore I3 is equal to integral over the curve C, f of z divided by z minus 2 dz is 0 since this point, because of this reason. Okay, now similarly let us work for I1 now. I1 is minus under integral sign f of z divided by z minus 1 over the curve C dz. Okay, as per the Cauchy's integral formula, since z is equal to 1 lies inside the circle, as per Cauchy's integral formula, so there is a minus sign, please don't forget that, minus 2 pi I, according to the formula, it is into f of 1. Okay, f of 1 earlier also we have solved. F of 1, your f is what? Should we write it here once again? F of z is sin pi z square plus cos pi z square. If z is equal to 1, you will get it to be minus 1, is it not? So minus 2 pi I into minus 1 you get, so it will be 2 pi I. Look at that. Okay. Similarly, let's work for I2. Integral over the curve C with negative sign, f of z divided by z minus 1 whole square dz you are having. Okay. So according to the, yes, Cauchy's generalized integral formula, a is equal to 1 whereas n is equal to 1. So it is 2 pi I divided by 1 factorial into f dash of 1 you get. Okay. So what is f dash of 1? Previously also we have solved. F dash we had got it to be 2z pi cos pi z square minus 2z pi sin pi z square. Is it not? When you put z is equal to 1 over here, what do you get? Just tell me. It will be minus 2 pi I into, you put z is equal to 1, it is 2 into pi, cos pi you get. Cos pi is 1, sorry, cos pi is minus 1, sin pi is 0, so directly this will be 0. So when you simplify this, 2 pi into 2 pi, it is 4 pi square I, minus into minus, it is plus. So I1 value, I2 value and I3 value are being evaluated. Therefore, for this particular integral, I mean integral over the curve C, I'll write it here, integral over the curve C, f of z divided by z minus 1 whole square into z minus 2. For this curve, mod z is equal to 3 by 2, you have I1 plus I2 plus I3 values. I3 is already 0. I1 value we got it to be 2 pi I and I2 value we got it to be 4 pi square I. I3 is 0. So let us add all together. You see that it is 2 pi I plus 4 pi square I. You can take 2 pi I common. You will get it as 1 plus 2 pi. Okay. This completes the solution for this problem. If you have any doubts regarding this, please do ask me in my WhatsApp group. Till then, thank you.